video, we're going to talk about right triangle trigonometry extended to unit circle. So we're not going to develop the unit circle, we're just going to use a unit circle to find our trig ratios. So as you look around the unit circle, we can see that on the inside going around, we start with 0 to 30, 45 degrees, 60, 90, 120, working our way back around to 360. On the outside in the blue, we see that we skip 0, but it's the same thing as 2 pi. Pi over 6, pi over 4, all the way back around to 2 pi. And then we see parentheses, which are our coordinates. So we have 1, 0, square root of 3 over 2, 1/2, all the way to 0, 1, and we have, these are our x and y coordinates that we're going to use to find our trig ratios. So 6 trig ratios: sine, which is defined as y over r; cosine, which is defined as x over r, where r is your radius; tangent is defined by y over x; cosecant is defined as r over y; secant is defined as r over x; and cotangent is defined as x over y. Example 1. Evaluate sine of pi and cosine of pi. So if we look at pi, we go to our unit circle and find our coordinates. That would be -1, 0. This is my coordinates. Okay, so sine is defined as y over r. Cosine of theta is defined as x over r. And r is always going to be 1 because unit means 1. Okay, so if we write sine of pi, that's going to be 0 over 1, which is 0. If we write cosine of pi, that's going to be -1 over 1, which is going to be -1, and we're done finding the sine and cosine of pi. 2. Evaluate tan of 90. So if we look at tan of -270. So 90 is our x and y coordinates. If we look up at our unit circle, it's going to be 0, 1. So tangent is defined as y over x. Our x is going to be 0 and our y is going to be 1. So this is going to be an undefined ratio. Now if we look at -270, so let's look at -270. So 0, -90, -180, -270. That's the same thing as 90. So tangent of -270 degrees is going to be the same thing as tangent of 90 degrees, which is going to be 0 over 1, which we know is going to be 1 over 0. Which we know is undefined. And we're done example 2. Example 3. The point -1, 0 is a point on the terminal side of an angle in standard position. Determine the values of the 6 trigonometric functions of the angle. So we're going to say sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. So what we need to do is figure out what point are we talking about. So we find the point -1, 0, that's 180. So we know our theta is 180. And sine is defined as y over r. Cosine is defined as x over r. Tangent is defined as y over x. Cosecant is defined as r over y. Secant is defined as r over x, and cotangent is defined as x over y. So our sine is just going to be 0 over 1, which is going to be 0. Our cosine is going to be defined as negative 1 over 1, which is going to be negative 1. Our tangent is going to be defined as 0 over negative 1, which is going to be 0. Cosecant is going to be defined as 1 over 0, which is going to be undefined. Our secant is going to be defined as 1 over negative 1, which will be negative 1. And our cotangent is going to be negative 1 over 0, which is also going to be undefined. And we're done example 3. Determine the values of the 6 trigonometric functions of 15 pi over 4. So let's write down our problem. Sine of 15 pi over 4, cosine of 15 pi over 4, tangent of 15 pi over 4, cosecant of 15 pi over 4, secant of 15 pi over 4, and cotangent of 15 pi over 4. So now we need our coordinates. So we find 15 pi over 4 on our unit circle. So we have 5 pi over 4. So if we look at our unit circle, we have 2 pi over 4, which will be the same 2 pi. We put that over 4, that would be the same thing as 8 pi over 4. So 8 pi over 4, 9 pi over 4, 10 pi, 11 pi, 12, 13, 14, 15. So 8 pi plus 7 pi over 4 is going to be the same thing as 15 pi over 4. Another way we could have found that is 15 pi over 4 minus 8 pi over 4, and that would have gave me 7 pi over 4. So the coordinates we need is square root of 2 over 2 and negative square root of 2 over 2. Square root of 2 over 2 and negative square root of 2 over 2. So sine of 15 pi over 4 is going to be negative root 2 over 2, because anything divided by 1 is going to be itself. Cosine of 15 pi over 4 is going to be square root of 2 over 2. Now we have tangent, which this is where it gets tricky. So tangent is defined as y divide x. So that's going to be negative root 2 over 2 divided by root 2 over 2. So we're going to flip our fractions. Negative root 2 over 2 times 2 over root 2. Everything cancels. So that's going to be negative 1. Cosecant is going to be defined as r over y. So that's going to be 1 divided by negative root 2 over 2. So it's going to be 1 times 2 over negative root 2. Rationalize the denominator. So we're left with 2 negative 2 root 2 all over negative. Let's fix this. This should be just multiply. That is a negative, but we only have to multiply So it'd be negative all over 2. So our final answer is just going to be negative root 2. Secant, same procedure. We're not going to take the time to do that. So that's going to be a positive root 2. They're almost the same. And then cotangent, when we divide them, it's also going to be negative 1. Same procedure as when we did tangent. And we are done example 4. Rise using a table. So in quadrant 1, so we'll have quadrant 1, 2, 3, and 4. In quadrant 1, in radians we go from 0 to pi over 2. And then degrees, that'd be 0 to 90 degrees. Cosine is positive, sine is positive, and tangent's positive. In quadrant 2, we go from pi over 2 to pi, or 90 degrees to 180 degrees. The x's are negative, so that means our cosine's going to be negative, our sine's going to be positive because that's the y value, and our tangent's going to be negative. And then in quadrant 3, we go from pi to 3 pi over 2, or 180 degrees to 270 degrees. X's and y's are positive, so cosine and sine are both negative, but a negative will be a positive, so the tangent has to be positive. And then in quadrant 4, we go from 3 pi over 2 to 2 pi, or 270 degrees to 360 degrees. And x's are positive, so cosine's positive, y's are negative, so sine's going to be negative, and tangent has to be negative. Hopefully this helps you have a deeper understanding on how to work with the unit circle with right triangle trigonometry.